Okay, we're looking at the second part of exercise number 28 where they ask us to use a graphing utility to graph the revenue function and identify the intervals of elasticity and inelasticity. Okay, so what I have here typed in my calculator in the equation editor is the revenue function. It's the demand function, which tells us the price per unit when we sell X units. Okay, so the price per unit times X, the number of units. Okay, remember, revenue is just X times little p of X, okay, the demand function. Okay, so we want to find the maximum revenue here, actually. Now they say find the intervals of elasticity, but let's make a little connection here. They say that when demand is elastic, okay, we know that means we're going to sell more units at a lower price to raise revenue. Okay, so what that means, sell more units will raise revenue. Okay, so that means whenever the revenue function is increasing with X, we're selling more units to raise revenue. So whenever the revenue function is increasing, demand will be elastic. And whenever the revenue function is decreasing, demand will be inelastic. Okay, because when demand is inelastic, you actually want to sell fewer units to raise revenue. Okay, that means the revenue function is going to be decreasing with the number of units you sell. Okay, so I type the function in and I hit graph. Okay, wait a second for it to graph, and of course I don't see anything. And the reason we don't see anything is that I'm just looking in the standard window here, and this function doesn't fit very well in the standard window. Okay, so I go back to the window feature. I'm hitting the window button here. And you got to play around a little bit to see what values of X, what range of X and Y values gives you a good picture of the function. But what I've found is, of course, we're talking about a revenue function, so we're never going to sell fewer than 0 units. So if I let X min be 0, that's certainly reasonable. And X max, I'm going to make 100. It turns out I think 100 gives us a pretty good picture. Okay, in the problem itself, we talked about demand of 20 units, so clearly it needs to be much bigger than 10, but I think 100 is a pretty good idea here. And X scale, I'll make every unit 1 tick mark, or every 10 units 1 tick mark, so X scale will be 10. Now again, Y min, well, we're really only kind of interested when revenue is positive, so the smallest Y value we'll look at is, say, 0. The largest Y value, well, in order to figure out what's reasonable, we kind of need to know how big the revenue function gets. But I tried a few different things, and it looks like if we make the Y max 20,000, okay, this will make our Y scale show up to the units, 20,000th unit of revenue, so $20,000 of revenue, then that'll give us the revenue function. But if I'm going to do that, I don't want a tick mark for every unit, because my Y-axis is going to have 20,000 tick marks on it. I'm going to change the Y scale to 5,000. Okay, that gives me a tick mark every 5,000 units. Okay, now when I graph the function, here's what you see. Okay, every tick mark on the x-axis is 10 units. Okay, so we're selling 0, 10, 20, 30, so forth. And what's our revenue? Well, it's 5,000, 10,000, 15,000, 20,000. Okay, so to answer the question about intervals of elasticity and inelasticity, I basically need to see where my revenue function is increasing and decreasing. So when the revenue function is increasing, demand is elastic, and when it's decreasing, which it is over here, demand is inelastic. Okay, so I can actually kind of use the calculator to do everything here. What I really need is this x-coordinate where everything changes. So the easy way to find that on the calculator is if I go to second, so let's scroll up here a little bit. If I hit the second trace, I get the calc menu, and I can actually find the maximum value of the revenue function. So I'm going to select that, and what you'll see here, if I want to find that maximum value, I can just hit a left bound, so I just pick some point on the curve. I'm using the arrows here to move left and right. I just pick some point left of my maximum, press enter, and then I move that little cursor a little bit over here to the right to give it a right bound. Okay, so I've effectively told it the maximum has to be between these 2 points. It asks for a guess. I just press enter one more time. And it tells me the maximum occurs right here when x is 66.666. Okay, so that's 200 over 3. Okay, if you want to think of it that way. So when x is less than 200 over 3, demand is elastic, or 66 66. We could round it to 67, I suppose. This is a number of units. So when we sell less than 67 units, demand is elastic. When we sell more than 67 units, demand is inelastic. Okay.